Okay, so in this example, in this video, we're going to do some practices for support vector machine by using R. And the first one we want to do is the linear support vector machine classifiers. So first of all, let's read into some data. So read.table is a very easy to use command to read in some normal txt data. In here we have a data called expdata1.txt, and the header equals to true. That means the first line of the data could be considered as the header. So if we give header true, so that means this command know your data having a header. So this command will consider the first line of your data as the header. So separate is a comma. So that means we tell the R command that our data is separated by the comma. Okay, so we can click on this. Okay, so we execute the first line. And we're reading the data, and we give all data. So this is the variable name of all the data. So let's take a look on the data type. Okay, it's a data frame. When we read from a file, usually the default data type is a data frame. So let's take a look, see how the data looks like. Okay, now we have 3 columns. So every column has a name, label, x1 and x2. Cool. And I want to close this. And what I want to do is I hope to plot the data for observation. So what I want to do is, okay, cool. I can immediately join this figure. Okay, so apparently we have 2 types of data. So the blue one and red line. They are more or less interacting to each other, so it's really not very easy to separating them if we're only using one line. But anyway, we're trying to separating by using a single line and see how accuracy we can achieve by using support vector machine. Okay, so this is our data. And if you want to using support vector machine, there's a very basic library called E1071. So this is a package developed by a university in Germany and in Berlin, Technological University in Berlin. Okay, you can Google this. So a very easy way is you just type in install.package and with a double quote E1071, you click on this and so you're gonna run that. But I actually installed this before, so I don't need to install this again. So after the installation, you can load in the library loading the package into your memories. Okay, now by using the library, now you have loaded the packages. Now you can basically use that. But before we use the support vector machine function, so we need to make sure the data we're going to fit into the support vector machine is a data frame. So yes, we have a data frame. So all data. So the data we type in, actually we read into here is a data frame. But if you try to take a look of, for example, with the US dollar, the label, we find out this is an integer. So the label is integer. Actually, we don't like the label to be integer. If we take a look on this label, for example, and the first lines, okay, the label could be -1 or plus or a +1. So just 2 classes, -1 or +1. So we're using the label to indicating the 2 classes. Okay, so what we have to do is we have to convert the label to be another type of data in R. So that is called factor. So to convert that, so the one way is that we're gonna using this. So S factor is how we're gonna convert label. It's an integer to a factor. So, and we're creating a new data frame in here. So in this data frame, we have one column called x1, so that equals to the original x1, and another column called x2, and that just the x2, and another one called y, and that is a factor. Factor is actually not a numerical one, so that's indicating how many categories. So it's actually a categorical data. So it's how many categories you are going to have. So we're using s dot factor to convert all data and with a US dollar label. So we convert the label to be a factor. So the label has to be a factor. So we are going to consider the two clauses by using the label. So we're gonna clicking this, and now if you take a look on the all data label, so this is an integer, but if you take a look on DAT, so this is the new data which is created, so y, so that's actually a factor. So this is the difference. Now we got a new data, DAT, so let's try to train a new SVM model. So an easy way is we're using a function called SVM, so this is embedded in the package. So y is actually our target. So with a dot, that means we're using all the other columns as x, and the data equals to DAT. So this is the data which is created. And kernel, we just using a linear kernel. So that means just basic support vector machine. And we give a C5 and scale. No, we don't want a scale because so far, we're just using linear one. We don't have gamma because we don't use kernels. We only have a C. That's actually the margin we're going to give the hyperplane. So we train this. Okay, after training, we already got the data. So SVM already got the model. So SVM fit, that should be a model. If we type in SVM fit, and okay, we can auto printing the model. So this is basically a C classification. It's a linear. We got a gamma 0.5. This is basically a default one. So we don't need to care about that. Okay, once we got the model, we can try to predict by using the SVM fit. Okay, so we actually train the model using DAT, the data. And after training, we use the same data for testing. So that means the results should be okay because we are using the same data. And so we try to take a look on how the output is. Now, predict is a function. We give a model and data, so we predict the results. So this should be a result by using our model and the same data. Okay, now let's create a table. So a table, we're going to use the predicted y and the original y. So DAT is the data frame we just created. With the US dollar, that's basically a way we're gonna referring to y. This is one column. So let's create a table of original y, original target, and a predicted target. And we assign this to confusion matrix. If we're auto-printing confusion matrix, we can have some results. Okay, now we have -1, 1. So we got some -1, so correctly classified, and some 1 also correctly classified. But apparently, the result is not very good. It's okay, it's not very good. So how to calculating the different measures? So we could, based on the confusion matrix, we can basically try to calculate the recall and precision. So by using this and this. And then after that, we can printing out the recall 0.89, the precision 0.88. It's not very good, but that's okay. So this is one way we're gonna using the linear support vector machine. Okay, now let's try to do another example, nonlinear kernel support vector machine. Before that, what I want to do is remove the previous data because we are going to using the same data with same variable name but different data. So this is remove. I click on this. Okay, now I don't have any all data and DAT. So now I want to read in some new data. So exp data2.txt. So the same command, I'm reading the data, and what I want to do is I select them all, so I pick this, I plot the figure. Okay, now apparently we got some new data. So this is the two classes, the blue one and red one. Okay, fine. So let's try to creating a support vector machine using nonlinear kernel and try to creating a hyperplane separating the two classes. Okay, so first of all, we hope to creating a new data frame called DAT. Okay, let's executing this. So the purpose is that we're gonna converting the label to be a factor. That means we're gonna creating the label to be categorical. Okay, now I have DAT. So let's take a look. What is DAT? Okay, so it's a data frame. And if you take a look on DAT and Y, that's your label. Okay, that's a factor. Okay, now let's take a look, see how we're gonna creating a new support vector machine. SVM, the same function. So the target is Y, and we are going to using all the other columns, and data is DAT. The kernel is a radio kernel is also called Gaussian kernel. And the cost is 15, we give a very big cost. And the gamma, because we are going to using a radio kernel, it's a Gaussian kernel, so we're going to have a gamma. So we're starting with, it's just randomly picked number, so it's a pretty small number. And we don't do any scale. Okay, let's try to run this. Okay, it takes just less than 1 second. And I want to auto printing this. Okay, print the model. Okay, we got a lot of support vectors, and this is a radio kernel classification model. Okay, let's try to do some prediction using the model SVM fit. This is a new created models, and using the same data. Okay, we do some predictions. Okay, and run this, and creating confusion matrix. And this is our confusion matrix. Let's take a look. So for one, that's okay. For one class, we can basically classify most of the class 1 to 1. That's correctly classification. But for -1, that's pretty bad. It's almost half of the -1 are classified to be 1. Okay, so this is actually not very good results. Let's try to calculate the recall and precision. Okay, apparently the recall is very low. Precision is fine, so that means this is not a very good model. Okay, let's try to tune some of the parameters. And so to tune the parameters for support vector machine, so we know we only have 2 parameters, the C and the gamma. C and gamma. Okay, we have a function called tune. So that's very convenient. So we're using the tune, and we give, first of all, tune what type of model. We tune support vector machine. So the first one is the model name, and the second one is Y. Okay, it's not second one is Y. The second one is the format of the function. So how we're gonna fit in the support vector machine? We hope to using Y as the target, and all the others is a dot representing all the other columns as X, and using the data of DAT and kernel of radio, and then the next one is a range. Range is that, so how many parameters we're going to consider. So apparently we have cost and gamma. So previously we just give cost just a one value and gamma another value. Now I want to creating a list for cost. So C is a concatenating, so C with a bracket, and so this is how we're going to concatenating a list of C values. We're going to try 15, 20, and 30. And there's another list of gamma. We're going to try gamma 0.001, 0.01, 0.02. So this is 3 gammas. So we're going to try to find a best combination of the 6 values. So it's not necessarily to be, we don't actually limit ourselves to be just 3. We can even have 4 or even more. So the more parameters you are going to have, the longer the time of the running is. So if you click on this, yeah, it takes maybe sometimes, but it should be very quick. Okay, so now, running is finished. So, and let's take a look. What is the best model? So, and the output of tune function is tune.output. And tune.output, we can have a US dollar and best.model. So if you click on this, so we print out the best models. So the best model having the cost of 30 gamma 0.02, that's the best models parameter. And that's okay, which is auto printing the parameters of the best model. Now let's using the best model for prediction. Okay, we're using predict, the same function, and the model is tune.out with a US dollar, the best model. Okay, cool. Let's run this and let's take a look again. What is the confusion matrix and what is recall and precision? Apparently, we have better recall and better precisions. The precision is increased to 90%. 0.9 and recall is much higher than the previous version. So this is why we hope to using a tune function to find out the best combination of 2 parameters. And we can also try slightly more combinations. For example, I want to try 5, 10, 15, 30, and 35. And for gamma, so what I want to try is, and this is 0.01, 0.02, 0.03, and 0.05, 0.1. Okay, so we have loads of different parameters. If we run this, that takes slightly more time. Okay, we can select it and click run. Let's wait for couple minutes. Okay, cool. Now we finish running. So let's take a look. What is the best model? Okay, now let's, the best model is a cost equals to 30 gamma is 0.05. And let's try to do some predictions and see how the result is. So it looks like maybe it's not as good as the previous one. It's a recall 0.88. So previously we have recall 0.86. Okay, slightly increased, but for precision, and we got 0.894. Previously we have 0.90. So the precision decreased a little bit, but recall increased a little bit. Okay, so this is sort of a trade-off. So what do you want to do? So maybe, and you want to make the recall and precision slightly balanced, or you want to have precision looks slightly high and recall slightly low. So I would say maybe this is a slightly better results for this product machine on this case. Okay, so and this is an example of how we're going to using tune and to find out the best combination of 2 parameters. Apparently, you can create a very long list, but if you create a very long list of cost and gamma, so that means you are going to run for a very long time. If your data is huge, so maybe you're gonna running this for many hours. That's also possible. Okay, so after this, what we want to do is we hope to using a very interesting example from the websites and from the Kaggle websites. So, and I think that this is a very popular websites for data science. So we're going to using a very popular and very famous example called Titanic data. So you can go to these websites and Titanic and to see what is the story behind this data. And this is actually a real data things. Okay, so this is the website. So Titanic, this is an interesting example of using machine learning for the disasters. Okay, so basically, and there's also an interesting video about Titanic. Okay, yes, an interesting one, a very good movie. So now, and in this website, so this is a data science website, they share some of the data of the survivals. So and now they hope that you can use the data to do some analysis of what sort of people were likely to survive. In particular, apply machine learning to predict which passengers survived in tragedy. Okay, so and if you click on the data, so you have the training data sets and testing data sets. You can log in and download them. So actually we have the data in Learn already, so we can basically download the data. So the first data set is called train.csv, and the second one is test.csv, and there's another one called gendersubmission.csv. So, and this is actually for the testings. Okay, so first of all, we're gonna reading to the data. CSV could be format files could be opened by Excel. So for most of the cases, we're not going to store the data into the .xlsx, that's the Excel format. Instead, we're going to using the CSV. And so this is a pretty clean and it's a faster format for R. So if you for every Excel files, it's very easily to save as a CSV file. So if you want to using R to handling your data in your Excel, so you can first save as your Excel file data into a CSV file, and then you can using R to reading to CSV. I'm not saying R couldn't reading an Excel format data. It is possible, but much slower than CSV files. So if you're reading a CSV file, it could be very fast. Okay, so the way to reading to CSV is just read.csv, and we give the name. So now, this is the 3 files are in the working directory, so I can directly reading the file name into R. So we give several variables, train data, test data, and test labels. Okay, let's click on this. Cool. I'm reading this, and reading the second one, reading the last one. Okay, first of all, let's take a look on the first data. Okay, so this is how the data looks like. And we have passenger ID, survived, so 0 and 1. So 0 means not survived, 1 means survived. So this is a class, and the people's name, and sex, age, and so I don't know what is this, and I don't know what this. So this is the ticket and the fare, the cabins, and embarked. So we don't have a lot of things and just several columns. And also we can view the test data, and apparently we have very similar so structures of the training data. And let's take a look. So what is the data type of the reading data? It's a data frame. Okay, so and we take a look. So this is all the column names of training data, and this is also column names of the testing data. Okay, so there are pretty tiny difference, because in the training data we have a column called survived, because we know the passenger survived or not. But for testing data, we hope to creating a model and reading the training data. And so because we know for training data, we know who is a survivor, who is not. So once we creating the data, so we're going to using testing data to have some test of the model. Once we're creating the model, okay. So First of all, we can clean the data. So why do we need to clean the data? So if we, for example, looking at the training data again, so apparently we're going to see some of the empty things at age. So here it is. So this is NA. So that means not available. Here it is again, not available. So we have several not availables in here. So we don't need not available. Okay, so for every column, we have the same length. So in total, the training data sets contain roughly 891 lines, but we don't actually need to basically redeem or use every single line, because at this column, we have a lot of not available. So this is an empty positions. So we can using a function called is.na. NA is not available. So we can using this and to test a certain column of the data. And so the return of this is going to be an index, actually a list having the same length of this column. At every position, if the column having a real number, so that will be false. If the column having an NA in here, so that will be a true. So let's take a look. So let's try to execute the first one. Okay, after execution, we are going to have basically, so this is an index. So NA index for training data. Okay, so let's try to view this. Okay, you can see false, 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 true. Number 6 is true. Let's take a look on training data set on the column. Number 6 is not available. Okay, so that means true, indicating the not available position. So following, we have another true, that's number 18. Let's take a look on this. Okay, number 18, we have a not available at age. Now we can understand, so this column. So this column also contains 891 items. For every item, it's a true or false. False means not and not available. And true means it's not available. It's an NA. So we're using this to creating a list. And then we know, okay, so this is the list and containing the not available positions. Okay, so we hope to just select all the data, training data, and without any NA. So we have this special symbols in here. So that means, and we give invert value of this. So let's take, what does it mean? Okay, so we created another one. So if for this variable, we using this and to give the inverted and a value, and to this new variable, and let's view this. And so this is actually a new variable. We have a true, 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 false. So the previously we have a false, 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 true. So actually we can see, so this is the result. And why do we need this in here? So that means we don't need any not available values. We hope to selecting true, 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 true. That will be the value selected. So we need the real values, and we don't need actually not available values. So we're using this to selecting the real values for training data. Okay. So we're using this to select for training data. So that means after this, we're going to have the training data set for the certain column age doesn't contain any not available values. Okay, let's try to run this again. And okay, let's do this again. And also we can observe there are some NAs in fair, this column. So we're gonna try to do this again. And okay, so, and why do we need to do this? Because the tested label contains 2 columns, so we're going to select in the second column as the tested labels. Okay, so after loading the data, I hope to starting with the tree-based models. And first of all, I want to load the tree-based model and attach the training data. After attaching the data to the R, so we can directly using the column name. So that's pretty simple. Okay, and the data has 11 features. So I don't want to use them all, so I want to use some of them. So I want to create a tree model using tree function. And so this is the first one, because the survive is just a 0 or 1, but it's not factor. I want to convert it to factor. And so this is our target. And then we have several X. So this is actually a selected, randomly selected. Okay, what if we only consider those features, those attributes? And data is a trained data. So I select this and click on this. Now let's take a look on how the tree is. Okay, so this is actually the tree is. I want to plot in the tree. Okay, let's take a look. So that's the final tree. And we only consider several things. Okay, so the first one, the most important is the sex. If she's a female, and we're gonna go into the left-hand side. So if a P class, okay, left-hand side, or we're gonna right-hand side. So survive, survive, not survive. 0 is not survive. Okay, very interesting model. Okay, so let's try to do some testing. We're using a predict function. We give a model, tree-based model, and testing data is a new data, and type is a class. That means we hope to do classification. We click on this and running this, and this is our prediction results. It's using the table to creating the confusion matrix. And take a look on the confusion matrix. Looks like, maybe it's okay. Because for 1, we have most of the 1s classified as 1, most of the 0s classified as 0. Looks like okay, so the tree-based model works pretty fine. And let's try to calculate the recall and precision. Let's select them all and run that. Cool, we got pretty good recall and precisions. So, okay, that means that works really good by using tree-based models on the Titanic data. Let's try to run another tree-based model by selecting different features. What if we're selecting fewer attributes? And what I want to do is I create another one and try to predict. And okay, so I want to plot in this again. So apparently we got slightly different models in here. And let's try to take a look on the performance. Okay, still the performance is not so bad. It's actually very similar to the previous one. Okay, cool. So the previous one, recall, and the new recall, they are actually the same. That's perfect. Okay, so now let's try to do slightly more than that. Okay, so we finish a lot of experiments. We can save some of the results into the CSV file. That's pretty easier for the future observation. And okay, and we can create a data frame. And the first column is called ID. We have passenger ID, and we have a predicted results. So that's actually predicted. And true results. So we convert them together as a new data set. That's going to be a data frame, and we can save this to your working directory by using write.csv. So we give it a name, treeresult.csv. So row name, we give it a false because we don't actually need any row numbers. But by default, we're going to have some column names. Okay. So this is actually the data frame we just created. So I run this, fine. I can basically save everything into a CSV. So after the saving, you may open your working directory, take a look. Okay, fine. So this is the saved results. I double click on this and I want to take a look how it looks like. So it takes some time to open that. Okay, cool. And it looks like this. So the first column is called ID. And so the first column is ID and the second column is called predict results. It's predict results. And the last column is called true results. True results. Okay, fine. So we can basically having all the results in here. That looks very cool. So basically most of them are correct. That's awesome. Okay. So, and after that, we can also write in our results into a txt. So by using write table, we don't want to try this. So okay, the next one, what I want to do is I want to just using random forest to have another test on the Titanic data. I'm going to loading the libraries, and so. Okay, so when we are using random forest model, what we hope to do is we're going to create a big data set containing both the training data and testing data. Let's take a look on how we're going to creating that. So first of all, I want to selecting certain columns, because usually we have different columns for training data and different column sequence for testing data. So I counting down all the data and data columns, and so this is actually the number of the columns, and correspondingly, so testing data have the same column names as the training data, but with different sequences. So I'm gonna creating a list of this. So this is concatenating a list of the column name, and this is concatenating a list of column name. So a comma in here, that means we hope to selecting all the rows for training data, and for testing data, we selected all the rows with a slightly different sequence of the column, but the same name. So we combine them as two rows together. That means so the training data will be on the top, a big block of training data on the top, another big block of testing data on the bottom. So we combine them together as a new data set called all data. So I'm running this, and let's take a look on all data. So, okay, so we have certain the columns, and so the first part on the top is actually the training data, and the later one are the testing data. Okay, so we're creating one single big data sets. So we hope to know which one are the training data and which one are the testing data. Okay, so we're gonna creating an index of training index and testing index, and also we hope to combine them together. Okay, so that's the training index. And so this is actually not a real label, just creating something empty for testing data sets, because for testing data sets, we don't actually have a label. So what I want to do is we're creating a list of this rep is actually repeating 0 for n different times. So this is a number of rows of testing data. Okay, and then I want to combine all the things together as a survive. So this is actually the labels for training data sets, but we have something empty there, so this is only for the positions of testing data. Okay, now I want to combine the survive, so this is a label and data together as a new data frame. Okay, so in this, I want to take a look on the new data frame again. So we have a survived. So in here, so this is survive 0, 1 or 0. That basically means and survive or not. But on the bottom, so we have all zeros. So that's basically a fake labels, because for the testing data, we don't actually have the data set. I don't have the labels. Okay, so and then I want to remove this survived and attach the new data sets. That's pretty easy for us to basically and using the different column names. So now what I want to do is creating a random forest. Okay, so I want to create a random forest by consider survived as the Y and those columns as the X. So X data, we're going to use in the new data, new created data frame, all data, and subset. So that means we're only using part of the data with the index of this, training data index. And N trees, that's actually the number of trees we're going to create it as a random forest. So we create 1,000. So let's select this and take a look. Okay, so that's actually not very slow. Let's take a look, see how the prediction is. So, and what I want to do is calculate based on the confusion matrix, and I want to print out. Cool. And we take a look. Recall and precision, that's fine, but it looks like the recall and precision are lower than the tree-based. So apparently, this is lower than the tree-based. So that means actually random forest doesn't guarantee an improved performance. So it only guarantee only improve the performance when you have unstable and data sets in tree-based models. So another features of random forest is importance. So if you're running this, importance is a function in random forest. Once you're creating this, because this is actually where it is, so RF, this is actually in the models. Yeah, we create a random forest model, and we using the importance, we can generating a new index. So if we running this, basically the index is how important the certain attributes is for the whole model and for the forecastings. Okay, so apparently we're generating the index, we give index an order with a decreasing order, and we list all the corresponding features. So we can see, so this is the importance. So the most important one is sex. And next one is a fair and age and class. So sex contribute a lot actually. So this is the highest score. So that means the sex is actually, so if you are a female, so probably you are given the priority to be survived. So that's the reason why sex is very important attributes. Okay, so maybe we can try some other features like this. So this is sex, fair, age, and PX. So this is the most important and top 4 most important features. So I try to run this again, and I want to select all the lower things together and run this again. So compare with the previously, so recall is increased a little bit, and precision is also increased a little bit by using fewer attributes, but the 4 most important features. Okay, so from this example, we might find out the random forest actually does not guarantee better performance than the single decision tree. So it actually is better if and only if a single tree suffers from instability. Actually, it doesn't work very well. So that's the only case random forest that could offering a better performance by creating a lot of different trees. Okay, so this is actually a simple example of how we're using random forest for this. And we can also try support vector machine on the same case. Oh, okay, I want to loading the library, and so we just running by randomly selecting some of the parameters cos and gamma, and we have some prediction results. Let's take a look how the performance is. Recall and precision is not very bad. So what if we tune the parameters? Okay, so this is the same as before. What I want to do is tune. I use the most important features. So, and I tune the results. Let's take a look and see how long it takes to achieving the final results. Okay, so yeah, we finished the running and we do some predictions and let's take a look how, the final and okay, cool. So the final result is recall is 0.98 and precision is this. I think this result is slightly lower than the single trait-based models, but it's still okay by tuning out. So let's take a look. So what is the best parameters? So okay, so the cost is 30, C is 30, gamma is pretty small. So that's the tuned parameter. Okay, now we're using a real example of Titanic data sets, and we take a look. We're using single tree-based random forest and support vector machine to try the same data sets. And one thing is when we are using the random forest, so we're achieving slightly lower performance, but we can actually run. Yes, we achieve a slightly lower performance, but we can actually using the importance function to find out the important sequence of all the attributes. And when we know the importance and sequence of all the attributes, we can select the top, and for example, top 5 or top 4 most important features. And we're running again the random forest or some other models, for example, support vector machine. So in support vector machine, we're only using the top 4 most important features. So this is actually random forest that could be a very good way to selecting the certain features. Are they important or not very important? Once we're using the random forest, so we can using the importance index and selecting them and training some other models. Okay, thank you.